From molten titanium to precision CNC machining, every stage of the APU installation is critical for the A400M.
The auxiliary power unit installation begins with a titanium ingot. High-pressure gas clears contaminants before ultrasonic probes scan.
Purity readings are consistent. The crystalline structure is flawless. It meets the A400M specifications.
No internal inclusions detected here. The density is uniform.
Excellent. That meets the A400M specifications.
A dedicated factory routing monitor displays a digital schematic showing the path of the titanium ingot.
Verified and the APU mounting bracket is moved into a specialized high-energy shot peening chamber. Microscopic ceramic beads are blasted.
The destination is confirmed as the A400M final assembly line.
The sealed crate containing the APU mounting bracket, Process A, is lifted by an automated guide. The machine works with powerful, fluid motion, slowly forming the precise, intricate shape required to navigate.
Robotic arms perform internal inspection using advanced fiber optic borescopes on titanium duct segments.
A newly welded titanium duct is moved into a vacuum chamber for stress relieving. The chamber doors seal. This insulation protects adjacent aircraft systems from the high temperatures of the bleed air passing through the ducts, ensuring thermal management within the confined APU bay. The newly insulated titanium duct assembly enters a large curing oven, where the thermal barrier coating is baked.
Sitter. A final leak test is performed using inert helium gas injected into the assembly. Highly sensitive. The automated inkjet system applies indelible markings onto the titanium duct assembly, aiding installation.
The pallet jack delivers the Process B ducting case, uniting it with the APU mounting bracket.
Check the alignment on sector 3. Tolerance is tight.
Green across the board. Torque sequence initiated.
The borescope is inserted into the bleed air manifold for Process B inspection. The internal view confirms the titanium.
Ensure the overlap is secure on this side.
Thermal blanket secured. We are clear for final inspection.
The APU operates at full load. As the thermal overlay shows, the white-coated titanium duct, Process B,
The auxiliary power unit provides critical climate control, enhancing operational efficiency. All right, next pallet, let's move.
The V-band clamps are secure. The thermal coating shows no signs of degradation, confirming long-term durability.
In isolated locations, the APU provides essential ground power, maintaining the A400M.
Okay, APU running smoothly. Check complete, 0 pressure drops confirmed.
The integration of the auxiliary power unit and the white-coated titanium duct assembly ensures the A400M will ground power.
The simulation results are conclusive. The titanium duct assembly surpasses the minimum operational requirements.
Excellent.
Confirming the parameters for the drop zone right here.
Acknowledged. We've balanced the load, relying on the APU and the integrity of this duct assembly for climate control.
APU start, confirm pneumatic power.
Engaging APU, pressure rising. APU available.
Status green, well done. The Airbus A400M is undergoing major service. The APU is removed, but the titanium duct assembly. The Airbus A400M performs air-to-air refueling, APU on standby.
A pilot gives a thumbs up, relying confidently on the APU for all onboard power. This gesture providing ground power for the Airbus A400M. The titanium duct assembly, process B. The final hero shot, from titanium ingot to the critical APU system, ensuring global reach for the A400M.